Climate change is not a new phenomenon. The Earth's climate has been changing for hundreds of thousands of years. Thanks to ice core data, we've been able to see a natural CO2 cycle in the atmosphere that happens about every 100,000 years. So what's the cause of this cycle? It's actually the Earth's orbit. The ice core data also shows that although CO2 didn't cause climate change, like in the examples of the Ice Age, it does have a global effect on temperature. There is an argument out there that's kind of circulating that says mankind is not causing climate change. And to an extent, that argument is true. Climate change is naturally occurring phenomenon. But something that we also need to remember and note is that currently we are seeing an increase in CO2 that breaks the 100,000 year cycle. So this is why so many scientists are worried about climate change. Even though it might be a naturally occurring phenomenon, we are entering a new era with unprecedented CO2 levels, and we're only just barely beginning to comprehend what that means. The current estimates of CO2 in the atmosphere are around 427 parts per million, which is about 127 parts per million more than the largest recorded ice core data. So the main contributors to this increase are the burning of fossil fuels and industrialization. So I have projected our current radiative forcing levels along with the worst case scenario to model effects of the effects that greenhouse gases have on four main factors: the CO2 concentration in the atmosphere, the surface air temperature, the sea surface temperature, and the planetary albedo. In each case, the increase in greenhouse gases has a direct impact on climatary responses. And I'm going to focus on what I believe is the main concern, which is the concentration of carbon dioxide in the atmosphere, specifically with its effect on the ocean. The ocean absorbs about 30% of the carbon dioxide that's in the atmosphere. And the main immediate concern from the increased atmospheric CO2 is the acidification of the ocean. So CO2 reacts with the water, which produces carbonic acid, and then that dissociates into hydrogen ions and bicarbonate. This increase in hydrogen ions causes the acidification of the ocean, so it lowers its pH level, and it has another effect on that it decreases the amount of carbonate in the ocean. According to the European Environmental Agency, the current pH scale of the ocean is around 8.05, with optimal levels being at 8.1. In a worst-case scenario, if we stay on our current trajectory, we make no attempts to lower greenhouse gases. The predicted amount of carbon dioxide in the atmosphere by the year 2100 is going to be somewhere around 927.2 parts per million. The pH level of the ocean then drops to 7.7. Now, this might not seem like a lot, but on a pH scale, it is a significant drop. The ocean, as stated before, it thrives at a pH scale of 8.1, which is actually slightly basic. And it's this basic consistency which produces carbonate. When the pH is lowered, as a direct result of the hydrogen ion, there's a decrease in carbonate, which is the building block of corals, mollusks, and phytoplankton. The NOAA has also shown that a lower of the pH on ocean fish can result in their reproductive abilities, which has a direct impact on their populations. Current climate change measures like wind and solar are effective on small scales, but on large scales have serious issues with renewability and sustainability. The resources to make these are often farmed with slave labor, and the maintenance and longevity are not optimal. Increased prices in gas and energy are also not a viable solution in that it does not have a significant impact on lowering usage and causes serious burdens on low-income people. To summarize the matter, we need energy to survive. This is why I propose nuclear energy as a long-term energy solution. Nuclear energy, coupled with the mass planting of bamboo trees, which are the highest CO2 absorbing trees, will enable us to stabilize CO2 concentration increase, giving us enough time to innovate and allow engineering solutions to find better renewable and clean energy solutions for over the next 75 years. According to Statista, there are about 2,422 coal plants in operation today. So as sourced by the International Energy Agency, the average CO2 emissions from coal plants is around 15 gigatons each year. So if we can replace all coal plants with nuclear plants and plant approximately 50 billion bamboo trees near or in urban areas, then we can start to curb CO2 emissions and allow us the time we need to find new and innovative ways to produce clean energy. This plan does not touch oil and gas, which are so widely used that any cut to them without producing an immediate affordable option to replace it will cause such hardship on low income and working class people that it makes it just something we cannot afford to take. So I have run a radiative forcing model to project our climate over the next 75 years under the current implementations. It considers current levels of CO2 with an attempt to either maintain their current levels or reduce them over the next 75 years. So this lowers the CO2 concentration from the worst case scenario, which was 927.2 parts per million, to a best case scenario of 421.9 parts per million. Also stated by the International Energy Association, the annual level of CO2 emissions is around 36.8 gigatons. Given that average CO2 absorption from 50 million bamboo trees to be about 1 gigaton a year, coupled with the nuclear power, this will reduce CO2 emissions to 20.8 gigatons a year. And this cuts the CO2 emissions almost in half. And under these proposed changes, projections under the optimal conditions now show pH levels of 8.056, which is actually slightly better than what we're currently seeing today. There's no question in my mind that we need to make steps towards curbing increased CO2 emissions, but we need to make steps that are practical and realistic and that do not hurt those who are already having economic hardships. Nuclear power has come a long way since Chernobyl, and although not completely without risk, is currently the best large-scale option for clean energy. Who knows what amazing new innovations in energy mankind can create over the next 75 years? We need to make changes now so that by the time the year 2100 comes, the oceans are still sustainable for the future. The method in which I use to calculate pH level from CO2 has to deal with the chemical interaction of carbon dioxide and H2O. They produce carbonic acid, which then produces hydrogen ions and bicarbonate. The other association that I wanted to mention is that carbonate, which is CO minus 2,3, interacts with hydrogen ions. The more hydrogen ions are there, the less carbonate there is, and the more bicarbonate there is. And remembering that carbonate is what sea animals use to thrive and flourish in coral reefs and phytoplankton, and bicarbonate is not. So the molar ratio is a 1-to-1 ratio. The current estimated levels for carbon dioxide are 428 parts per million, given that 30% of what's in that's the atmospheric amount, right? So 30% of the atmospheric amount is in the ocean, and parts per million is a milligram per kilogram. So if we associate then that with grams per kilogram of water, it is 0.128 grams for every kilogram of water. And given the density of water to be roughly 1 kilogram per liter, we can just associate that with a molality, which is what we're going to get to, but currently we have 0.128 grams per liter of water. If we then use the molar mass of carbon dioxide, we get that it has 0.002918 molar, which is the molars are moles to liter. And then using the pH scale, which is a negative log of the hydrogen ion content, we can find that from the CO2 absorption, it contributes 2.535 to the pH level. So if our given pH level is 8.05, there is some consistency of 5.15 from other sources in the ocean that are contributing to that pH level. And currently right now we're just going to project just from the increase of CO2 how that affects the pH scale, assuming all other conditions remain stable. Now that we have an idea of how much the pH scale is varied by all the other conditions, we can set up two cases where we measure it using the worst case scenario and the best case scenario. So the worst case scenario, as stated before, if we make absolutely no changes to the environment, 30% of the atmospheric CO2 gets absorbed. We're left with a pH that's effectively at a 7.71 overall for the ocean. And in a best case scenario, we actually end up curbing fossil fuel usage eventually. Even just the cutting of the carbon dioxide emissions from coal plants can give us a pH, again, best case scenario, pH level of 8.056, which is actually slightly better than current calculations. Bamboo rate absorption is based on a hectare of space. So under the assumption, because bamboos do not take up a lot of surface area, we can fit about 2,000 bamboo trees in 1 hectare of space. And about 1 hectare of space of bamboo trees absorbs about 38 tons a year of carbon dioxide. If we compute that calculation, for 50 million bamboo trees, we need 25,000 hectares. And that kind of accumulates to approximately 1 gigaton of CO2 absorption each year. So how that accounts to the overall absorption rate, as stated, the overall CO2 emission is 36.8 gigatons each year. If we subtract from that, essentially eliminating coal CO2 emissions by replacing them with nuclear, which virtually have no CO2 emissions, and planting that 50 million bamboo trees, we reduce it to 20.8 gigatons each year, as you can see in the calculations.